Okay, so welcome back. Now, let's now continue with a question that also involves a graph, and this is one of the more complex ones, right? So it's not just involving reading a graph, but it's also going to involve simultaneous equations, and we'll see how this is done in a moment. Okay, so the question reads, the siren of a train moving at constant speed along a straight horizontal track emits sound with a constant frequency. A detector placed next to the track records this frequency of the sound waves. The results obtained are shown in the graph below. Okay, so there they show you some frequency over there where it's higher and there it's lower, right? And now you notice that you see the word detector. There's a detector, it's placed next to the track. Okay, and so the detector serves as the listener. That's what you must remember here. This is the listener. Okay. The siren of a train, the siren of the train that is moving. Okay. So in other words, the source is moving. And we don't have the speed. If you see here, it's not giving us the speed. They're just telling us it's moving, right? A detector placed next to the track records the frequency of the sound waves. Okay. So we know this point over here from our previous question. This is when the train passes the detector. Are we together? And here it's approaching the detector. And here it's moving away from the detector because it's past it. Okay. And how do we know it's approaching the detector there? It's because it's got a higher frequency, higher than what the true source frequency. And on this side, it's moving away, and therefore it's got a lower frequency, so higher and lower. Now for 6.1, remember you need to memorize the Doppler effect definition, and you must do it in such a way that you give us the definitions the way it is in the exam guidelines, right? So I'm going to put it here. What is the definition? It is the change in frequency of the sound, okay, detected by a listener. The change in frequency of the sound detected by a listener, right? Because the sound source and the listener have different velocities relative to the medium of sound propagation. That's the definition in the examination guidelines. Okay? Relative to the medium of sound propagation. That's 6.1. 6.2. Does the detector record the frequency of 3148 when the train moves towards the detector or away from the detector? Now there we say it's approaching, so the word here must be towards, right? So that's what you're going to write down. Usually the question will say write only blah blah blah. Okay. Now 6.3, this one we're going to have to work out some stuff, and it says calculate the speed of the train. Take the speed of sound to be 340 meters per second. Now, again, in general, you want to write down your formal Doppler effect formula, which is the frequency of the listener is equal to VL over VS multiplied by Fs, right? Plus minus, plus minus. Now, we're going to set up some kind of an equation, and remember the frequency of the source is true in both scenarios. So what we need to do here is for this equation, we will then have a situation where we're going to map out towards, and we will have a situation which we map out away. Now in towards, you're going to have the frequency of the listener is equal to V, right? But we know that the listener is stationary. This here, VL is equal to 0. And how do we know that? We know that because the detector is placed on the train tracks. It's not moving. So we're going to just have V on top because the value of VL is 0, right? Meters per second. So this will be V. And here at the bottom, I'm going to have what? I'm going to have 340, right? 340. And now we need to know, is my Vs going to be lower than or greater than? Now in this case, it's going to be you're going to subtract from the denominator because we want the entire fraction to be bigger than, we want it to be bigger than 0, right? So this is going to be a minus Vs, and the top V's value is going to be 340. Now, the only mistake that I'm making here is I'm catching on nonsense, to be honest with you. Although what I've put in is totally correct, I want to write down the Doppler effect formula here for the case itself. So it's going to be V over V minus Vs. That's my manipulated form. And when it moves away, it's going to be FL is equal to V over V plus Vs, because now the numerator is bigger than, smaller than the denominator. And then that gives me a fraction that is less than 1. So in this case, and this one is greater than 1, right? Now I'm going to go and substitute in. Frequency of the listener. Okay, so as it moves towards the frequency of the listener, I'm going to now substitute as 3148 is equal to 340 over V minus Vs. So it's going to be 340 minus Vs, and that's going to be multiplied by the frequency of the source, which we weren't given, right? And on the away side, I'm going to have 2073 is equal to 340 over 340 plus Vs multiplied by Fs. Okay, now look at this. You need to observe that I have two equations with two unknowns, right? So the unknowns are Vs and Fs, those two. Now what I'm going to do is, because this Fs in this thing and this Fs in this thing are the same, okay, they're the same thing, I'm going to make that the subject of the formula, because when I have two equations with two unknowns, I can use simultaneous equations to solve. So let's do that. Okay, so I'm going to keep it in blue. I'm going to say that that is 3148, right, multiplied by this denominator, which is 340 minus Vs divided by 340 is equal to Fs. Okay, and then on the other side, what I'm going to do is I'm going to say I've got 2073 multiplied by 340 plus Vs divided by 340 is equal to Fs, right? So that's what you want to check. We've got, and then that means in the new denominators, I got 340 minus Vs, 340 plus Vs, 2073, blah, blah, blah. Okay, so now I'm going to equate these two things. That and that are the same thing. So therefore, this will simplify into the following. This is going to simplify into 3148 times by 340 minus Vs over 340 is equal to 2073, was it 73, yeah, into 340 plus Vs divided by 340. Now at this point, students, what you can do is you can go do a little bit of, you got 340 on both sides, so that's going to fall away, and now you multiply these things out. In fact, yeah, so here you can go and calculate that quickly, multiply that by that, that by that, that by that, that by that, get all the Vs's to one side, and you should get a final solution of Vs is equal to 70 meters per second. Okay, 70 meters per second. Are we good? Let me put it here at the bottom. Vs is equal to 70 meters per second, right? So as you would know, I don't like to do too much algebra here because the rest is just algebra. Now the next question is, the detector started recording the frequency of the moving train siren when the train was 350 meters away. Calculate the time t1. So in other words, this distance that it covers is 350 meters. You also happen to know that you also happen to know that it covers 70 meters for every second. So if you covered 350 meters and 70 meters per second, that means you took 5 seconds. Does that make sense? How can we look at this? Well, we can look at speed, right? What is speed? Speed is your velocity. It's equal to delta x over delta t, which is distance over time. So we can then simplify this or manipulate this to make t the subject of the equation. That becomes delta x over the speed, and the distance that we covered was 350, and we did so at 70 meters per second, and therefore my time is going to equal to 5 seconds. Okay, so that brings us to the end of this question. Nothing hectic, nothing difficult, but almost 10% of the paper free of charge, guys. Okay, and well done, and see you soon.